I'd also like to begin by acknowledging the traditional custodians of the land on which I am speaking to you from, the Gadigal and the Wungal people of the Eora Nation, and pay my respects to elders past and present. So I'm just going to share my screen here. Okay, I'm guessing everyone can see that. I can't see anyone anymore. That's interesting. Okay, great. So I'd like to talk to you today about this work, Computer Learns Automation, as a work that I created for the Adelaide Biennial Monster Theatres, which exhibited at the Art Gallery of South Australia at the beginning of 2020, just before lockdown and pandemic struck. The work consists of what I did for this work is created several different environments, virtual environments in the game engine Unity 3D, in which machine learning agents would try to achieve a particular task. So, and for the machine learning component, I used the Unity package ML agents. So the three components are robot arm, which you're seeing on the screen here. And I'll just jump over to show you also if this will work. Rideshare, which is looks something like this, and drone strike, which is a aerial view of a unmanned aerial vehicle. So basically this work, I'll show some video of this a bit later on, but basically in this work, I'm using reinforcement learning to train these particular machine learning agents, but they're being trained in real time. So the exhibition was scheduled to run for approximately 100 days. And that the time that it would be open from the public is 10 a.m. to 5 p.m. So I was creating environments in which the machine learning agent would learn approximately, or have a decent chance to learn the task and be able to achieve proficiency in the task over the course of training for about 8 hours a day, 8 or 9 hours a day for 100 days. And so in this way, I was showing the audience every step of the training. The generative aspect of the game engine, in which the game engine itself, the computer program, generates each frame in real time, 60 frames per second. But also I found that I could complete the training in real time as well, so that a certain number of observations were taken from each frame and the different various positions of objects in the virtual scene. And these were used to train the model in real time over the course of that 100 days. And I think what I was really trying to do here was show machine learning as a process, as something that unfolds in time, but also find some way to show the entire data set, or to show the entire training process, and have that be in some way transparent, rather than training a model that would then be the renderings or the outputs would be shown later. In doing so, of course, I did make the data set incomprehensible because no one would sit in the gallery each day for 100 days, of course. But I really like the idea that viewers could look at the exhibition at the beginning and see an agent that didn't know how to navigate the space, or didn't know how to complete the task, and then come back at towards the latter part and see a very different process unfolding. So I'm just going to play a few little excerpts of each environment at the beginning of training, and then towards the end part of training. And I'll just let you know when I'm switching. The work also has a sound component, in which another machine learning model was trained on 6,000 MIDI files of Super Nintendo soundtracks, and then these generate the soundtrack. This model generates the soundtrack for the next day the night before. So the sound is also generative in some sense there. Okay. So that is rideshare at the beginning of training, and after only 700,000 steps. And then I'll show you a video of rideshare after 49 million steps of training. And moving on to drone strike after only 2 million steps of training. And then drone strike after it's trained for 47 million steps. For some reason, in this part of the screen recording, the agent goes exploring the mountains and has lost the target. And then onto robot arm after 600,000 training steps. And then 40 million steps towards the end of the exhibition. Okay, I might get out of screen sharing now. Okay, great. I can see everyone again. So I guess a couple of things I wanted to add about that. The three scenarios that I created, I chose because they're different examples of where machine learning and automated decision making is being used in the world, and particularly being used in ways that are either opaque or sort of beyond what we're normally presented with and normally aware of, but also ways that are having increasing importance or have been very, very significant socio-politically. I wanted to use these three works, and so in the exhibition, they're shown alongside each other on 3 screens on one gallery wall. I wanted to use these 3 different environments to create some connection to the broader use of machine learning in different contexts, and find some way to engage directly with machine learning with the tools and use the tools to make the work, but also somehow speak to or find some connection to contemporary issues of labor, automation, and value. I think, yeah, I was also in this work thinking a lot about video games and gamification and the abstraction of particular tasks into an isolated environment. And I think this is something that we see commonly throughout the world, but particularly in techno-utopian thinking. And the last thing perhaps on this is that obviously I was trying to use some degree of humor and playfulness in the work. I think there's something quite darkly funny about watching a machine learning agent that drives into the wall repeatedly, but then after a few months of training is now driving passengers from place to place and avoiding obstacles, and as sort of that process has been sort of unfolding in the gallery space itself. I think that's about all I want to say about this. I guess just one final point is that in making this work and in thinking about this area and working on it for a long period of time, I ran into some really difficult limitations on making artworks in this format. And I think perhaps the one thing that's kind of invisible in this work, or the most obviously lacking thing, is the labor that I put into the work in trying to make the environments. And I think like Anna Ridler talked about this in the keynote, like it's really hard to sort of balance all those different factors and to make work using machine learning that requires some level of scale and these levels of data storage, but also computation and technical proficiency, that it's hard to balance all those and to combine them into a work. And so, yeah, this was my attempt to try and make some gestures towards that. Yeah, it's a topic that I also feel like in conflict with. But it was a very interesting work to make, and yeah, very, very glad to be speaking about it here today. So thank you.